Welcome to this section of the Geometry Tutor where we're going to continue our discussion of geometry, and we're going to move into really one of the core fundamental sections of geometry that everybody thinks of when they actually think of geometry, and that is the concept of an angle. Okay, we're going to talk about what an angle is, and we're going to talk about how to classify angles, and you're going to have a lot of weird words in here and a lot of foreign terminology, but we're going to make that clear so that when you're reading your book and doing your homework, all of that will make total sense to you. Okay. So I guess the first thing I want to ask you is, what do you think an angle is? Okay, an angle is a unit of measure. Okay, and it's used to measure the distance between two rays that are apart, that are set apart from one another. Okay, now let me see if I can explain that a little bit better. If you have a line segment, let's say something this long, you can put a ruler up and you can measure that the distance between this and this is 8 inches or 10 inches or whatever it is. And you can go off in your car and you can drive down the road in a straight line and you can tell me how many miles it would take you to drive from point A to point B. That is a unit of measure. It's a distance, right? We call it distance. We measure in miles or inches or whatever. Okay? But let me ask you this. If you had a line set, a ray, I guess is what I'm trying to say here. Okay, starting at point B and traveling through point A, and we talked about rays in the last section. This is a ray, BA. Okay? This is ray BA. I'm just showing you how to write it, but this is the ray I'm talking about here. And then attached to this common point here, I drew another ray, okay, that started at B and it went through the point C. So this one is BC ray, okay? I have ray BA and ray BC, okay? And this common point here, we're going to call it the vertex. The vertex. Again, all this stuff is just terminology. Once you learn the terminology, it's simple. You can kind of think of vertex anyway because it kind of sounds like apex almost a little bit. Vertex is that point where the two rays come together. That point, that's called a vertex. Okay? So two rays, this ray and this ray. Okay? So how would you express how far open they were? Okay? Because obviously this is this is open this far right here. Okay? But I could have two other rays that were closed a little bit more. I don't have to draw the dots here to show you, but there's two rays there, okay, like this. Or I could have them opened up a lot farther, like this, right? And what if I'm interested in measuring how far open they are? Okay, this one's open a little bit less, and this one's open a little bit more, okay? And how do I want to do that? Well, I have to use the concept of an angle, okay? So an angle, it just is the measurement of openness between between two rays. Okay? Openness. That's the best word I could come up with. Vertex is at the point. So basically, this angle right here, we put a line in here, this little arc right here. That means there's an angle here. Okay? So this angle is bigger than this angle, right? Because this one's almost shut, right? And in fact, I could draw one that was really tiny here. This openness is very small here. So this angle is bigger than this one, and this angle here is bigger than all the rest, okay? So an angle, in the simplest, most layman's terms, you have to have some way of measuring how open something is. I mean, think about it. You open the door, okay? If you just barely crack the door, we say that it has a very small angle, that it's opened at, okay? But if you open the door wide open, there's a big angle there between it and the wall. We say the angle is bigger. So what you're getting at here is when we measure distance along a line, that's what we call linear measure. That's what we're used to every day. But it turns out in math and engineering and other sections of science, it's really important to be able to measure how far apart something is whenever they're joined at the hip like that, and that's called the angle, okay? So, from a geometry point of view, how do you write this angle? How do you write this angle? Well, it takes 3 points to form an angle, just like we have it drawn here. You have to have a vertex and you have to have your two rays, so there are 3 points. So the way that you would write this angle would be A, B, C, and you put a little angle symbol in front, okay? A, B, C, okay? Or angle C, B, A. Now let me talk about this. What you're doing here is you have some rays and you have an angle, what we call an included angle in the middle, okay? And we're just going to write this down, and we're going to use the letters to show us what's going on. A, B, C, with a little angle symbol in front means the angle between A and B and C, where B is the vertex. So the middle letter is always the point here. So the middle letter would be the point here, the point here, the point here, and you just put the other letters around the edge here, and you just kind of use your fingers, and you're lining them up so that you can kind of recreate what the angle is. And the order of the end two letters, they don't really matter because CBA, ABC, they're measuring the same angle. Okay, they're measuring the same angle. Okay, so let's do some more examples. Let's say I have an angle that looks like this. And my two rays that I've used to define the angle are D. E is the vertex point, and F here. So I've got a ray ED and a ray EF, and I've got a vertex here. So how do I write this angle? Where this angle, by the way, is right here in the middle. That's what this little symbol means here. So you would write that down on your paper as angle DEF or angle FED. FED. Okay? So you just go around the edges like this. DEF, FED. As long as E is in the middle, you're okay. Now, what if I had one like this, where I've opened up quite a bit? Okay, there's nothing that says it has to be close together. I can open the door way far away, and I can say, well, what if I had something like Q here, R at the vertex, here at the point, and let's say over here I had S. So there's a bigger angle here. Okay, this is obviously a bigger angle than this one. It's open more, right? So how do I write that down? I say angle QRS or angle SRQ. Okay? So you can see all you're doing is you're going around the points through the vertex and back out again, and that's how you write that down. Now let me ask you this. Which of these two angles do you think looks bigger? I think we just talked about that. This angle is bigger than this one because it's more open. Okay, that's all that means. So you would say, if you wanted to write that down, you'd say angle QRS is greater than, just like any old greater than symbol, angle DEF. So this is just like, the statement 5 is greater than 2, or 10 is greater than 3, or something like that. So angle QRS is greater than angle DEF. That's all you're trying to say there. Okay? Okay, now let's talk about the unit of measure for degrees, for angles. Unit of measure for angles. Well, we use the term degrees. Okay, I think you've all heard that before. Degrees. Okay, so we're saying conceptually that this angle right here between my two arms, like this, okay, is greater than this angle, right? The door is open just a little bit. It's a very small angle. The door is open much wider. It's a bigger angle, okay? And that's true, but we have to put numbers to this thing. We have to be able to assign numbers so that we can do math with them, okay? So you have to have a unit of measure. For distance is inches or feet or centimeters or meters. For angles, in a geometry class, you use degrees, okay? So you use degrees. This is not degrees Fahrenheit or degrees Celsius. This is a completely different type of degree, okay? So how do you do that? Basically, the ancient mathematicians came up with this, and the best way to explain it is just to tell you that one circle is equal to 360 degrees. That's something you're going to have to remember, okay? You know that there are 365 days in a year. You know that there are 7 days in a week. You know that there are 24 hours a day. You know that there's 60 minutes in an hour. And all this stuff you're going to have to remember in the same way that one circle, one time all around the circle, has 360 degrees, okay? Let me explain a little bit what that means, okay? If you start here, okay, and remember, an angle is just simply measuring how open something is. So I can measure, okay, if I start here and I start going around and around and measuring how open it is, and open and open and open and get all the way back to where I started, okay, again, this is an angle. I just continue making the angle bigger and bigger and bigger until I finally get back to where I started again. Then I am saying that I have traveled 360 degrees in that one circle. So what this really means, and I can't draw it on the board here because I'm just not a good enough artist, is that if I split this circle into 360 equal slices, then each one of these slices would have a degree, an angle right here of 1 degree. Because I need 360 degrees to make the whole circle, so each one would have 1 degree. Okay, that's all it's saying. It's just one of those things. It's like the sky is blue, the sun is yellow. This is where you start. One circle is 360 degrees. It's a mathematical definition. From there you move on. Okay, from there you move on. So don't ask yourself why there's 360 degrees in the circle. I'm telling you that the ancient Greeks figured that out, and they defined it just like there's 60 minutes in an hour, and you just go with that as you go forward. So knowing that there's 360 degrees in one circle, okay, knowing that, then it shouldn't be too hard to figure out that a half circle measuring, like this, I start measuring bigger and bigger and bigger angles, and then I just go halfway, okay, half circle is equal to 180 degrees, okay, 180 degrees. Now here's something you can actually use a little bit in everyday life. We always talk about, boy, he did a 180. Boy, he was thinking that he was going to go to Sonic, and he did a total 180, and he went to Burger King. So that means he went and he turned around, he did a total 180. We use that every day in our life, okay? A 180 just means you're going one direction, and then you turn around and you go the opposite direction, okay? Well, here, you've started here, and you haven't gone full circle, because if you went all the way around the circle, you'd be back to where you started. You've gone half circle, right? So you've gone halfway, you've turned around, you were pointed this way, but then you're now going this way. So it's 180 degrees. That's where that comes from. 180 degrees is half of the circle, which is 360 degrees, okay? And so knowing that, you can then further start chopping up the circle more to a quarter circle. And I guess you can figure that out, and that's going to be 90 degrees. Because all you have to do to get to a quarter circle is divide the half circle by 2, right? So if you start here again, and you start measuring up like this, you've only gone a quarter of a circle. Because remember, your circle would continue on like this. Okay? So here the circle would continue. You've only gone a half circle. Here you've gone a quarter circle. It's 90 degrees. So you just keep dividing by 2 like this, and you'll get that. Okay, now that we've talked a little bit about angles, conceptually what an angle is, that it's just a unit of measure between two rays, okay, that have a vertex here, and they go off like this, smaller angle, bigger angle, like this, okay? And we've talked about the unit of measure, degrees, 360 degrees being in the circle, and just going from there, chopping up to a half circle, quarter circle, and on like that. Now we're going to classify angles, okay? We're going to classify angles. Okay, the easiest one is the one I'm going to start with first, and that's called a right angle. Just like it sounds, right angle. Okay, a right angle is equal to 90 degrees. Okay, so we've already learned that. I already told you that's a quarter circle. Okay, a right angle is 90 degrees. So let's look at that. How would you draw a right angle? Here's one of your rays. Here's the other ray. Okay, and we're going to say, let's just say here, this is point A. The vertex point here is point B, and the other ray is defined by B and C, so I have A, B, and C, okay? So what I say here, okay, if you think about it, if I'm measuring this angle right here, if I go from here and I start measuring up, can't you convince yourself that this is a quarter of a circle? Because this is a quarter, this is a half circle, this is the other part of the circle, and here's the whole circle. So once I've gone here, okay, I've gone to 90 degrees, okay? So angle A, B, C is equal to 90 degrees, which implies, that's what this symbol means, right angle. Right angle, okay? And you can say the same thing. Angle CBA is equal to 90 degrees, which means it is a right angle. Same thing. I mean, you can write the angle any which way you want, okay? Now, this is fine and dandy, have A, B, and C, but there is a very special symbol for right angles. Anytime you see it on your sheet of paper, if they're trying to tell you it's a 90-degree angle, they will put a little box here in the corner. So that's a special symbol, and all that means is when you see that, it's 90 degrees. That's all you have to remember, 90 degrees. I'm trying to point out the important things that you'll see and that you'll use in your problems over and over again. So when you see this, you will know automatically that is a 90-degree angle, that is a right angle, okay? Okay, the next thing we're going to do is we're going to classify angles a little bit further, and we're going to say that we have something called an acute angle. And all that means, okay, is an angle, that's what the symbol is, angle with, that just means with, less than 90, and I'm going to put a little degree symbol up here, 90 degrees. That's all that means. Acute angle is an angle with less than 90 degrees. So just remember here, okay, this is a right angle. Okay, that means you have a line, and you have a line perpendicular to it that goes straight up and down like this. That is a right angle. Okay, that's a 90-degree angle. Acute angle is an angle with less than 90 degrees. Okay, so let's show some examples. Here is roughly 45 degrees. It's less than 90 degrees, so that's an acute angle. Okay, here's something kind of close to 30 degrees. Okay, that's less than 90 degrees, so it's an acute angle. You know, and even if you have something relatively tall, okay, let's say this is 80 degrees. It's almost quite to 90, but it's not quite there. It's not quite opened up far enough. It's 80 degrees, which is less than 90, which means it's an acute angle. So all three of these are acute angles. And, you know, it's silly, but just think about it. You know, it's cute. It's so cute. It's a small little angle. Okay, that's how you remember that. Okay, now let's talk about another kind of angle. When we're classifying our angles, called an obtuse angle. Okay? Well, what do you think this is going to be? If an acute angle is less than 90 degrees, then an obtuse angle is just an angle with greater than 90 degrees. Okay, so that's all it means. So let me give you some examples of obtuse angles to show you. Again, this is a right angle, just for reference. So if I have to have an angle bigger than that, it needs to even stretch past this point. So let's say something like this. This is 135 degrees. This is a rough measure here, so that's an obtuse angle. Okay, you can have something that's very, very open. Oh, that's not the best drawing in the world. Let's do something like this. Something that's open really, really far. Okay? Let's say it's like, 165 degrees. That's an obtuse angle. Okay? So the acute angles are really close in. The right angles are exactly perpendicular to one another. And then anything past is obtuse. So this is an obtuse angle, obtuse, 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 right angle, acute, 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 acute. Okay? That's what that means. And there's one final thing that's kind of important. It's sort of silly, but you have something called a straight angle. A straight angle. And really all a straight angle is if you have, point A, point B, and point C. Okay, they're all on the same line. So the angle here is exactly 180 degrees. So anytime you have something that's exactly 180 degrees, it's a straight angle. And you can see why it's a straight angle. It's just because it's kind of a straight line. So just to summarize, you have the acute angles with the really narrow angles, less than 90 degrees. Less than 90 degrees is acute, 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 acute. Now you have the right angle, exactly 90 degrees. Then you keep going. Obtuse, 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 because it's greater than 90. Obtuse, 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 obtuse. Now exactly at 180 degrees, you have a straight angle. This angle right here is exactly 180 degrees, so that is your straight angle. Okay, now the next thing we want to do is we want to do some practice. So we can practice learning and identifying the acute angles, the obtuse angles, the right angles, and the straight angles. So I'm going to draw a big picture on the board. It's going to look complicated, but once we pick it apart, you'll see that it's not complicated. So here's point C, here's point E, okay, and here we have a line going through like this. This is point A, this is point D, and right over here, this is point B, and you have arrows everywhere because these are lines. They go on and on like this. And now you also have this right angle symbol. So this is a good example of a problem you might see in a book and a problem that might scare you a little bit. It's like, wow, this is a complicated looking picture, okay? You just have to pick it apart and do what you're told to do. So you know this is a right angle here, which means this angle is 90 degrees. That's all you know about the angles in this picture. That's all you know. You don't know anything about the measure of these angles here, but you know this one is 90 degrees, okay? So the question is, which angles are obtuse? Okay, there's lots of angles in here obtuse. We're just going to list a few of them, but it's good practice. Which angles are obtuse? I forgot to say that the center point here is F, okay? Remember, obtuse are angles that are bigger, let me see here, bigger than 90 degrees. So this one here, AFE, is bigger than 90, right? Because this is for reference. This is a right angle. This one is certainly bigger than 90 degrees. So you have angle AFE. AFE, that's bigger than 90 degrees. It's obtuse, okay? And then you also have BFD, this angle here, between these rays right here. Now notice there's an extra line in here. Just ignore it for right now. When I say angle BFD, then it doesn't matter whatever else is on the drawing. I'm only looking at B, F, and D as the vertex. I'm looking at this angle between these rays right here. And I can tell you right now, since this is 90, this is definitely greater than 90. So that's an obtuse angle. Okay? So which ones are acute? Which ones are less than 90 degrees? Okay? Well, this is less than 90 degrees. You can tell by looking at it. I mean, this is up and down, perpendicular. This is 90 degrees, so this one's got to be less. So angle DFE is acute. Okay? Angle CFD, this angle right here, that's acute. That's less than 90 degrees. Okay? And just to pick another one, BFA right here. BFA. We're just getting some practice identifying some angles. This angle right here is less than 90 degrees. It's a cute little angle here. It's less than 90, so it's acute. Now, do we have any straight angles? Now, remember, straight angles are just angles that have opened up and they're 180 degrees like this. Okay? Are there any straight angles? Well, this is all on the same line, right? So this angle is 90 degrees, so this one goes over like this. So you have BFE. That's a straight angle. And you have another line right here, AFD. AFD. This is a straight angle, okay? And so you can get some practice identifying some angles, the obtuse, the acute, and the straight angles, just simply based on if they're greater than 90, less than 90, or equal to 90. And as one final exercise, let's do one last thing. Instead of looking at this picture, just erase this picture from your head, and I'm going to write down 10 degrees. Is it acute, obtuse, or right angle? Well, it's less than 90 degrees. 10 degrees is certainly less than 90, so that would be an acute angle. 10-degree angle is really narrow. I mean, we're talking about 10 degrees. It's pretty darn narrow, okay? 130 degrees. Is it less than or greater than 90 degrees? That's all you have to ask yourself. It's greater than 90, so that's obtuse. Okay? 180 degrees. Is it less than or greater than 90? Well, it's greater than 90 degrees, but it's a special case that 180 degrees is the straight angle, right? Straight angle. And finally, if you have a 90 degrees, well, what is that? Is it acute? No. Is it obtuse? No. It's exactly equal to 90, so that is a right angle. That's a right angle. So don't forget, angle is just a unit of measure, how far open or closed something is. You label it by looking at the points in the vertex, just like we've done here. And you have the acute angles that are less than 90, the right angles that are equal to 90, and the obtuse angles that are greater than 90. And you have the straight angle that's exactly apart from each other, 180 degrees. And that's it.